Hello everyone, I'm Jason Young, JYoung8607 on Discord. You may have seen me, and you may know me as the Volkswagen guy. I have a very good friend who tends to go all in on technology hobbies. He got us into quadcopters back in the day before they were popular. He went all in on home automation. He's trying to get us all to build combat robots, which I don't know if I'm going to do unless we're going to get Billy and Silly to duke it out here. But back in 2018, he handed me an Eon, a giraffe, and a gray panda. And he said, I bought this, but I can't make it work on my car. He had like a 08 Acura, something or other. But do you think this would work on that Golf R you just bought? Because in the repository, there's this file called VW MQB. Do you know what that is? And I'm like, no, but I'm gonna find out. 5 years later, I'm on the stage at Comic-Con, so as you can see, that one kind of spun out of control. So, in my day job, in my corporate life, it's a habit to introduce myself with a couple of personal facts. Usually that personal fact is, I drive my car with a cell phone. But that doesn't really move the needle in this room for obvious reasons. And we're kind of past cell phones. So my random fact is the 8607 is my Cisco CCIE number. The guy in my Discord profile pic is a famous actor that's played in an old Volkswagen ad campaign probably 20 years ago. And I've had 5 total strangers approach me in airports, restaurants, whatever, and tell me I look like Tom Hanks. I don't see it, I don't get it. I love Tom Hanks, I'm flattered, but it's just a thing that happened to me. So that's my random personal fact. So today we're going to talk about how to port cars. This will be very generic. I'm going to use some examples that are drawn from a Volkswagen world, but this is not a Volkswagen specific talk. We're going to start off and talk about, is a car a good candidate? This doesn't mean we can know in advance if your car will work. You're going to have to go kind of all the way through the process to verify that, but there's some red flags that we look for. We'll talk about what you need for a dev environment. We'll talk about connecting to the car for the first time, reading data, and translating that into something that openpilot can use. We'll talk about sending messages for the first time, finding the actuator commands that your car's factory lane assist camera and ACC radar use. And last, we'll talk about the process of upstreaming cars. So, 3 classes of cars here. It's a good sign if your car has lane keeping assist and adaptive cruise control. Those are really minimums for supporting openpilot on your car. Yeah, you can hack around it, but it's not a good openpilot experience if you don't have adaptive cruise, and lane keeping assist is a minimum. And the other thing is we want to make sure it uses standard CAN or CAN-FD networking. Bad signs, some higher end cars don't use CAN, they'll use something called flexray. And flexray is, in a way that's hard to explain, and actually I'm not qualified to explain, it is hard to split openpilot in the middle of. Comma did a hackathon type thing that actually made this work on an Audi Q8, but I think they decided it was going to be a mess and hard to bring to market and didn't really proceed with it. It is difficult, and right now there's really no way on the market to work with it. If there's automotive Ethernet in the car, that's starting to become common in new vehicle designs. Right now we don't have transceivers for that. It's something you can buy. It's not hard to get on Ethernet itself. The trouble with automotive Ethernet, as manufacturers refresh to that, is it has a strong tendency to come with secure onboard communication, which is a euphemism for there's cryptographic hashes on messages that stop you from messing with things. FlexRay is just challenging to intercept. If your car has SecOC, as unfortunately Toyota and actually certain VW are starting to have, you actually have an adversary. Someone's trying to stop you from having fun, and that's going to be a little bit difficult. So I think both of those will be surmounted eventually, but they're going to be very vehicle specific, and they're not something I'm personally working on, and that's going to be a task for someone else. If your car doesn't have any of this stuff, you might actually have an easier time. There's some folks that actually bolted an electric power steering rack and a bunch of microcontrollers and some other things into a late 70s Volkswagen Vanagon. Now, after that was done, that Vanagon kind of identifies as a Toyota Corolla, but it works. So in some ways, that car on the right is actually easier than this car in the middle. So let's say you have a car that's likely to work, in this case mine, or whatever car that you might have. And I want to be clear that what I'm talking about here today is actually not that hard to do. If you can spell Linux and SSH, you can go through these journeys that I've gone through. It used to be a lot harder than it was, but it's gotten pretty easy. So first thing, workstation, something running Ubuntu, VMware, or WSL is fine. I'm about half and half bare metal Ubuntu when I'm working from home. This laptop running Windows 11, I do the other half on under WSL 2. Next thing you need is a comma 3. I missed the memo on it not being a dev kit anymore. Comma 3 or 3X. And when you order it, you'll order it with a developer harness, which I'll show you in just a moment. The return window for these guys is normally 30 days. I'm not sure what the process is, but if you're working on a new car port, they will give you a little bit of extra time. And then you'll need a few basic tools. You'll need a diagnostic tool for your car. It's a must. You're going to tick off your car during this process, and you'll need to be able to clear faults, and you'll need some visibility into what's going on. And you'll need some other basics, multimeter, wire cutters, crimper, etc. So when you order from the comma store and you get a developer harness, that's what it'll look like. It looks like any other harness adapter that they sell you, but there's no ends on it yet. You get to put the ends on it because whatever ends that it needs, the connector shells and the terminals, are going to be unique to your car. You can figure that out by looking at the connector cars on your car. There'll usually be a part number on it somewhere. The one end will usually be easy to find. The other end is sometimes rough because that's not something the manufacturer ever has to supply in a harness form. It's always built into the camera. In a pinch during development, you can make do with generic card edge, pin headers, but one way or another, you need to take that and adapt it to your car. And this is how you do it. Every auto manufacturer in the US and really worldwide will have some way for you to get access to repair info. It's not going to be free. You generally have to pay for it. If you go to irwin.vw.com as an example, but you can do this for any auto manufacturer, you can get a wiring diagram for any given car. And you can't really read this and you don't have to, but that will tell you how your camera is wired up, what's on what pin. You take that together with commas, open harness wiring diagram, and that'll tell you where you need to put constant power, ignition switch power, ground, can high, can low, an optional second can, and any pass-throughs that you need for like a camera heater or a fusion bus, so on and so forth. So let's assume we've made that harness and we've connected it to our car. This is what we need to figure out for openpilot to work. This is a subset of what goes into carstate. We need to know how fast the wheels are turning, what the steering angle is, what gear you're in, all that good stuff. And in order to learn that, we look at Cabana. I promise the next slides will be easier to read. I wanted you to see the whole window this time. But what you're looking at right now is a pile of numbers. And this looks intimidating, but it'll clarify pretty soon. By the way, before I forget, this tool was made by another external contributor named Dean Lee. I think Adib asked him one day, hey, do you want to do something about cabana because the web cabana is getting really crusty, and then you just bang this tool out in like a couple of weeks and has been growing it from there. And it is a game changer for reverse engineering CAN networks. So Dean Lee, if you're seeing this, you're the man. We love you. So I'm not going to step through every single one of those signals. I'm going to take you through 3 examples of some of the more complex ones and a couple tricks of how to find them. So cabana, that Dean Lee wrote, will show you and highlight bits that are changing. To find wheel speeds, you're looking for 4 signals that scale with how fast the car is moving. They stand still when the car is parked, and they move linearly when the car is driving. So somewhere in that pile of numbers is cabana is going to highlight ones that change in about the same way times 4. So we now know 4 wheel speeds, but where do they go? Get in your car, you'll take a test drive in a parking lot. Set your parking brake, and then take off from a stop, drive a figure 8, stop, and look at your logs. Front and back will identify themselves because when your parking brake is set and you're driving a front wheel drive car, as most folks are, particularly with the parking brake set, the front wheels will start rolling first. So now you know front and back. When you drive that figure 8, the outside wheels will turn faster. So as we're making this sweeping tight right turn, the outside wheel is turning faster. And that tells us left and right. So now we have front, back, left, right. We know where all the wheels are. Next, you'll do a simple test log for gas and brake. Usually I press the gas 3 times, press the brake 3 times, take it in, look at it. The accelerator will have a curve that goes up and down. It's pretty obvious. It's not an on and off. You'll find a percentage somewhere. You may need to scale it. You'll find a similar signal for brake pressure that'll be some sort of curve, and it'll match when you're pressing the brake. And by the way, there's some features within Cabana that you can say for all those signal changes that it's highlighting, you can say kind of freeze those and clear those for this little 10-second time window and just show me the ones that changed within there, and that'll start making things like this pop out. And then it's nice to find a signal for brake pressed. You can do that in a pinch by just showing brake pressure above 1, but that doesn't work for all cars. Sometimes the signal's a little noisy. This ends up being the source of a lot of bugs. Common chased a lot of these out. When at Eve and Shane were doing improved testing for cars and chasing down controls mismatches and so forth. Brake pressed can come from a lot of sources. There'll be a switch on the brake pedal. Often there's redundant switches. So you may be seeing those. You may be seeing something from the ABS controller that says brake pressure over a certain threshold, and those are all good. But you might also be seeing something that says open the brake shift interlock, or if you're driving, this might actually be a brake light signal, which sounds cool until you remember that your ACC, when it's slowing down, also fires off the brake lights. So you want to go ahead and flag all the signals that are potentially brake pressed, but come back and look at it and make sure it's actually only flagging the ones that the driver presses it. Now for steering inputs. I've got a particular way that I like to do this. Get in the car, start it up, and you'll turn the wheel to 45, 90, 180, full lock and hold it, let go, and then turn it back to 0, 45, 90. And that gives you a steering angle. Unfortunately, my laser pointer doesn't show up really well against this screen. That'll give you your steering angle and the scaling, since when you turn to 45, you know the value you should get is 45, 90, 180. Sometimes you have to watch this on progressive ratio variable steering racks, but this one happens to be pretty easy. So that'll give you the steering angle, the direction if it's separate. Sometimes it's combined in an assigned value, sometimes it's separate. In this case, it's separate. It'll also give you the amount of driver input torque. This is important for torque blending as you're driving with openpilot, so that openpilot can back off the guidance that it's giving you if the driver's providing input, and also so it knows which way you're nudging for desired inputs like lane changes. So it'll show you here, as we're steering, that EPS link moment, it'll show you that we're providing some input, and then high input, when we're holding it at lock, it'll go to 0 when you release, and you'll see that the direction sign is different because as we're turning the wheel back, we're providing pressure, torque, going left, even though the total steering angle is still right. We haven't crossed 0 yet. So with that simple test procedure, that gets you all the scaling that you need, all the directions that you need. So we take that, plug it in with Cabana, and that outputs a DVC, which goes into an openpilot car state and tells openpilot everything that it needs to know about what your car is doing, how fast you're going, where the wheel is, etc., etc. There's a lot more signals you'll need to hunt down eventually, but those examples should kind of show you how to use Cabana. The next thing we do is figure out how to send messages. There's very few that we want to send. The ones that we do want to send are the factory lane keeping assist messages. And we're just talking about lateral for now because I have 20 minutes to get through this. This is usually, from the factory camera, it's usually a torque signal. They're usually sending a command saying, turn the wheel this hard in this direction. It's not a direct command to follow this lane, whatever. The camera is saying, turn the steering wheel this hard. Sometimes the camera does send an angle. I think Tesla does this. I think Nissan does this. I haven't looked lately. Recently we had one come up that sent a path curvature. I know this drove Cameron nuts for a while when he was bringing Ford on board, but he got that figured out. He had to do some clever reverse engineering to turn that into something openpilot could use. So take note of what your factory camera does to actually control your car, what type of signal it sends, and what the maximums are. And then we teach openpilot to do that. In order for the car to actually pay attention to this message, we got to talk about payload, checksums, and counters. You may notice in most or all the messages that your car sends, there's a counter. There's some field somewhere that just rolls over and over and over. It counts up one every frame. Sometimes it's 2 bits, sometimes it's 4 bits. All the VW ones happen to be 4. Some other makes are 2. You also see a payload checksum of some form in a lot of messages. This can come in the form of literally a checksum, add up all the byte values and take the remainder. Sometimes it's an XOR over the message payload. Sometimes it's an actual CRC. In the case of Volkswagen, it happens to be a strangely modified CRC that took forever to figure out. In some cars, it's completely random. I've seen the algorithm for Chrysler, and I have no idea what they're doing there, but somebody figured it out. The key thing that you want to look for and hope for is if you see on the left side of the checksum there, if the message payload remains the same and you get the same checksum for that every time, there's something there that you can replicate. And you just have to figure it out, and there's tools for that now. There's a tool called CRC Beagle that you can get off GitHub that you feed it whatever byte value you're getting and this payload, and it will figure out, it may not figure it out completely automatically, but it'll do a lot of the drudge work that I had to do manually 5 years ago. If on the other hand you see randomness, if the payload and other values aren't repeating cyclically, if it's fully random, you might be having a bad day because that might be a cryptographic hash. you might have run into sec OC. If that's the case, you might be leveraging that return policy. Let's hope we don't see a ton of that, but that's what to look for. So let's assume we've got the steering message figured out. Cabana is going to write out that DBC for you. You're going to go into openpilot and have the car controller actually send out a torque command. And by the way, you actually don't have to take care of figuring out, at no point do you have to worry about where the car is in a lane, what direction to go, how to turn the wheel. openpilot takes care of all the path planning for you, and it already has a built-in controller for how much we want to turn the wheel. You just have to kind of figure out, you have to develop that Rosetta Stone of here's how to express a torque command to the car. And that is what we want to do. We want to send a torque command with that direction and match some other stock values that were used. And in this case, deeper levels of the OpenDBC library are handling the checksum and counter for us. And that takes us to what is hopefully good news. This picture was taken on an early, icky January morning in 2019. On the first day I made that thing work. Let me tell you, that was a good day. That was a fight to make that work. I think it took me something on the order of 3 months. And that was with several people helping me and providing hints. And there was still a ton of time in the driver's seat looking at TMUX, fixing typos. Oh my God, I can't believe I made another typo. Controls crashed again. Wait, why isn't the device starting anymore? It's back in the day, openpilot was a lot less testable, verifiable. That infrastructure that we have today didn't fully exist yet. But once you get it running, that first time that you feel openpilot engage and provide some guidance to the wheel, you're having a pretty good day. If your car makes it an entire minute down the road, and preferably more like 10 minutes, you're having a real good day. But sometimes you can get all the way into this process and find out you've got a lockout. And that's bad news. Sometimes there's workarounds for that, but every car that has a modern level 2 ADAS system will not let the driver go hands-off indefinitely. The difference is who enforces that. Some manufacturers drive that entirely from the camera. And if it's the camera that's deciding whether there's driver input and whether to disengage, openpilot can replace that. A few manufacturers, I think some varieties of Mazda, not recalling others offhand, but Old Ford, okay. Sometimes that 15 or 30 second lockout is enforced on the EPS. In that case, well, that's a bummer. Sometimes there's workarounds. There's things you can play with. Don't give up immediately. Reach out for help. But it's not a great sign if it consistently breaks after the same number of seconds. But hopefully you get down the road. And if you do, that's fantastic. You've got a lot of cleanup and quality work to do after that to make it good. Don't worry if it doesn't drive well at that point. You can fix that. As long as openpilot can take control for 5 or 10 minutes, this is going to work. So that was my day in 2019. This was Wednesday. What you're seeing here is the next generation of MQB called MQB Evo. This is a 2022 GTI. We rented earlier this week. We modified a harness that's not unlike one of the ones we use on VW right now. We moved a couple of pins around. There actually is automotive Ethernet in this car, but we don't care about it. It's used as a replacement for the fusion bus between the camera and the radar, but we just pass it through, don't listen to it. The stuff we do care about is CAN FD, and they rototailed some of the messages, and we had to go through a process of reverse engineering again. But openpilot is a very different product today. The carports have been massively cleaned up and standardized and templated. There's CI tests that mean you can take a log and play it back through controls and verify that everything works the way you think it should and doesn't crash before you get up from your desk. You're not doing this from the driver's seat anymore. You have tests that will check all this stuff out. And then new cabana will help you out with this. And the whole thing ends up being a lot easier and faster. Last time this took 3 months. This time we had it done in 9 hours. To be clear, it's not upstream yet. This is probably the worst possible week to ask a Dave and Shane to look at upstreaming a PR, but it's in progress. So, guidelines for upstreaming. It needs to be safe. It needs to comply with all of the guidelines that Adib and the rest of the openpilot team laid out earlier today. It needs to be passing tests. You need to verify all the checksums and counters, not only for sending, but also for receiving. And you need to make sure, if you're using stock ACC, that openpilot can reject engagements if there's something wrong. Then it needs to be supportable. It needs to work like other openpilot cars, and that means torque blending. That's one of the reasons Tesla isn't listed as officially supported, because the steering API doesn't work quite like we want. There needs to be no visible faults. It needs to drive in a way that would be acceptable for a person. And if there are faults, you need to log them and upload them so they can be analyzed later. This comes into play as part of all the work that the openpilot team has done to improve quality in MTBF and autopilot, to the point where the last couple of times that the openpilot team has had me look at routes that experienced faults, we tracked them back to a bug in the car. One of them was a retrofit that somebody had retrofitted ACC to the car. They didn't have it from the factory and they'd used the wrong software. The other one was genuinely a software bug in the ECU. A certain model year of Atlas had engine ECU firmware that if you did the wrong thing in the wrong order with remote start, you wouldn't have cruise control for the next start. So you want to get to the point where everything works. And then it needs to be actually marketable. In order for it to be upstream and actually appear on Comma's website and shop, you got to figure out how to make that harness manufacturable. It means you got to find the other connectors on the other end. It needs to be something somebody can reasonably install, and it needs to be fully plug and play, fully reversible. It needs to work like the openpilot experience in other cars, because it's one thing when you are working on your own car, but when this is upstream and in a store, it's not you that's taking the support calls or the RMAs or the angry emails, it's those guys. So it needs to be dialed in order for it to appear for actual sale to actual customers. So that's my talk. There's obviously a lot more that goes into it. I hope to actually do kind of like a blog series later. I don't know when that will fully come to pass, but hopefully that should be an overview. Anyone got questions?
Jason, we're going to do questions. We're running a little over.
Oh, all right. Okay.
I'm going to give you a little spot in the back, and everyone can come up and ask you questions back there.
Okay.
Get their specific questions answered. The comma team upstairs, if you guys want to come on down.